Hey there, Chem Squad. In today's class, we're going to look at how to adjust the titration formula. So, let's suppose that you're given this particular neutralization reaction. I'd like you to write down the reaction, try to balance it out, as well as write down the data that's given. Okay, so once you've balanced this reaction, you'll realize that this is a 3-to-1 ratio. Okay, so have 3 moles of base and 1 mole of acid. We'll also balance out the water on the other side, so we should need about 4 hydrogens on each side there. Oops, sorry. My mistake. There's 3 hydrogens here, 3 hydrogens here, so there's 6 in total. So this should be a 3. This should remain a 1. There we go. Alright, so what matters the most is your side with the acid and base. Okay, so according to Stoich, you have a 1-to-3 ratio between your acid and base, and because it's not a 1-to-1 ratio, okay, we simply can't use the regular titration formula the way it is. So we are normally seeing the titration formula as MAVA equals MBVB. Okay, and normally if you plug in all of our values, so you have 10 mils, which is of acid. The MA is 0.1. The VB is 10 mils again, and they're asking what is the molarity of your base. Well, if you put it into the standard titration formula that you see in front of you, the value will simply be 0.1 molarity, okay, of MB. This is assuming a 1-to-1 ratio, but because we have a 1-to-3 ratio, we have to make sure that we adjust it. Okay, so here's the thing. From your equation, we're saying that we have 3 moles of base and you have 1 mole of acid. But in order to equalize everything, okay, it's common for people to think that because the 3 is in front of the base, that you put a 3 on the base side. It's actually the other way around. Because we want to make it equal, right, since we have 3 moles of base, the acid side has to balance. Okay, so we actually put the 3 on the acid side, and the 1 goes on the base side. Okay, so we basically switch the acids and bases around in terms of its mole ratio. So this number here, okay, the 2 values that are from our reaction is technically called our mole ratio. So we need our mole ratios to balance each other out. So on this side here, we have 3 times the amount of moles of acid versus base. Okay, so when we do our calculations now, let's enter in our values. Okay, equals 1 times MB, which is what we want, and VB, which is 10 mils as well. Okay, we're going to divide both sides to isolate the value of molarity of base. Okay, And we'll notice that these cancel out. Okay. The volumes on the left-hand side, in our case, cancel out too. Okay, they won't always, but because we used equal volumes of acid and base, it makes it easier for it to cancel out. And in the end, your MB is basically 3 times 0.1 molarity divided by 1, which basically is 0.3 molarity. Okay. So our base is actually 3 times stronger than our standard solution of acid. Okay, because 0.3 is 3 times stronger than 0.1. Okay, so this part here reflects the mole ratio. Okay, and without adjusting it, you would actually have the wrong value for MB, because we would assume that MB would be exactly the same as your MA in this case, if you just use the titration formula as it was. So always use, always adjust your titration formula when it's not one-to-one. Titration formula when the ratio is not one-to-one. Okay, so hopefully this little video is helpful. Okay, if you still have problems with this, okay, come see me. I'll show you in the classroom. There's a bunch of different questions that we can look at and have you practice so that you get the hang of it. All right, that's all the time I have for today. See you guys later.